computer networking from past 23 years. I've done my PhD also in computer science, computer networks actually. So today, the topic that I'll be covering is around cloud security in general, whereas specific to telcos. Okay, so because this is one of the significant change that has happened in a few 3-4 years back, and the security has been one of the very interesting problems that a lot of researchers are working. Okay, so my understanding of the audience in today's call is a lot of them are from academia. Am I right? So can you help me to understand the audience? So Surendra, so do you think, am I right? Majority of the audience are from academia. Am I right?
Yes, sir. They are from academy.
Yeah. So, so considering the thing, so my assumption is you'll be more interested in the research activity in this domain of security in general, and telco cloud or cloud security in particular. Okay. So what I'll be talking needs a lot of background information actually. Unless you're working in this domain of telecom cloud, or even in general in cloud domain, it would be very, very difficult for you to appreciate or understand what I'm talking in today's session. Okay, so I will, depending on your current knowledge on cloud and telecom networks thing, we can make a decision on how deep we can go or how much we can go on this thing. So I would expect you guys to interrupt me. It is okay for you guys to just interrupt me in asking questions, or you can also post the questions in the chat and you let me know how do we want to do the interactive session part, I think. Okay. So my understanding, so if I'm right, I think a lot of you are quite familiar with the cloud, I think. Is it okay, or should you want me to spend some time on cloud also and then move on to the telecom and then move to the cloud, telco cloud security aspect? Okay. So anybody has any opinion before I continue? So if you have no opinion, then I will give a brief, quick. Sorry. Yeah, I think maybe that was just a. Was there any question or any point there, or it was just a interruption? Anyway. Okay, so we will spend quickly some time on the cloud, around 5-10 minutes thing, and then move on to give a brief about what's happening with these telcos over the past 4-5 days. What is that significant change, and how has these telcos have changed their culture itself over past few days? You yourself would have noticed over past few months, in fact, the kind of investments that's happening in Jio and Vodafone and Indian telcos, and how their whole business itself is changing from providing just the connectivity to services such as shopping and other things, right? So why this trend has happened and what's happening there? So we will look at it, and why these telcos are slowly becoming like Amazons and Googles of the world, and what kind of security challenges they have. So that's what we will be seeing today, and what kind of standards that are enforced in these security, and finally I would want to cover aspect of open sources that are very good and available in this domain of cloud security, that you would want to take it up in your research activity and work on that. Okay, so this is the high level flow. I'll continue by going with this flow if nobody has any comments on. Okay. Okay. So I will frequently check if there are any chat questions in the chat. If there is any, please put it on the chat, or you can interrupt me. Right. So considering the heterogeneity of the audience that might be here, I would not go into deep into explaining about the cloud. I will just try to keep it as easy to understand as possible. Okay, so maybe I will go to the full screen mode. Yeah, so this is the company I work for, Spirant Communications. Okay, so for our today's session, to keep it simple, we will just take this as the definition for the cloud, right? And it's a very simple and easy definition, and it's not far from reality. Okay, so for simplicity, it's just someone else's computer. Okay, so whatever you do, you're not just doing on your computer; you're just running it on someone else's computer. Okay, so we will go ahead with this understanding of the cloud, and it's a pretty easy and nice to understand whatever the concept that we want to discuss today, and it captures a lot of essence that we'll be talking in terms of security thing. Because we will be moving everything, our applications and everything that we are running to someone else's computer. Okay, and so the idea is basically very simple. You have a resource kind of which is underutilized, right? It could be your car or it could be your house, for example. So whenever you find such kind of a resource underutilized, there are options for you to share it with somebody else, right? For example, in your house, you can sublet it out, or you can go to Airbnb to share it with someone else for a time period thing. Or similarly for the car, you do the carpooling thing, or a timeshare with your neighbor. So this resource, whenever any resource is kind of underutilized, sharing is a very common and very pretty old and a very simple idea there, right? So the same concept is been taken here, where the resource in cloud is shared across the many people who would want to use it, right? So in our case, the resource in cloud is mostly at three things that you should remember. So today's this is one of the important takeaway point. The resource in cloud, when we use the word resource, we will refer to compute, storage, and network. Okay, so these are the three main resources in cloud that is very critical and that's been shared and used by multiple users. Okay. So I would usually use this analogy, right? So imagine you have your laptop, right? So, and you would have bought this laptop for maybe some particular reason, for maybe for academic purposes, right? So for your academic purposes, you may not have efficiently used your laptop for some reason. Thing. You could have used very less kind of thing. So you will come up with the idea of, hey, let me share my laptop with someone else. For a money or for a favor or for a free or whatever you would want to decide. So this sharing like has to happen over a network. Okay, you cannot take your laptop to someone else and give it to physically for him to use it for some period of time, right? Even that is possible, but that is not what we are talking about here. So here you have a very significant amount of very high-end laptop which is not efficiently used. You would want to share it with your anybody who would ready to pay. Okay, so if somebody asks me, hey, give me a 4 GB RAM and 4 core and 1 Gbps from your laptop, you would say, yes, give me 100 rupees per hour, kind of thing, right? So this is what a very similar analogy is similar to what's happening in the cloud. Okay, now you would so imagine doing this for thousands of laptops. Okay, and move this concept from laptop to a server. I will come to the point what I am referring to a server here, and how do they look, just for your sake of understanding, right? So the place where thousands of these servers are placed and allow people to share it is what typically referred as a data center. And these data centers are usually situated on the banks of river, mainly for the cooling purposes. But the idea is very same, or exactly what I mentioned in the laptop use case. You set up these kind of servers, thousands of servers, and allow people to give them these kind of resources, compute, storage, and network over the internet, right? So it has to happen over the network. Now, to manage, if it is only one laptop, it is very easy for you to manage. But to manage thousands of servers, it is not so easy to manage. So that is where the concept of virtual infrastructure managers come. They do exactly what we did in the single laptop use case, but they can do it across thousands of laptops or thousands of servers, right? So one such very, very popular virtual infrastructure manager, maybe you would have heard of it. It's called OpenStack. Okay. And that is a very popular infrastructure manager that has been used in a lot of enterprises and also telcos, and predominantly in telcos. Okay. And so why someone should use my laptop, right? Or why someone should go to the cloud in this case? Okay. So basically, they can just save money on the laptop. They don't want to buy a laptop only to get a 4 GB of RAM, and they don't want to buy a low-end laptop also, or they don't want to buy a big laptop with just for this particular resource. So they can save the money on buying the thing. They can save money on electricity. They can save space. Okay, and they will not have any maintenance headache of that particular laptop. Just change the word laptop to server here. It all means the same. Okay, I'm just keeping it laptop, considering to keep it easy, and it's post lunch, right? You're already feeling sleepy, and if I don't want to put you guys, I want to keep it as easy and nice as possible for you to get to the point here. And they can scale the resources anytime. Today you want 4 GB, tomorrow if you want 8 GB, you need not go throw the old laptop and buy a new one, right? You can just ask the guy, whoever is providing you the resources, to scale it. And you can also ask that you don't want, you need only for a specific time and duration. You can say, I need on Monday, Wednesday, and Friday from 10 to 12, whereas Saturday and Sunday 3 to 5. Okay. And this is precisely what the cloud is, right? So even in cloud, you can do exactly these 5-6 points that I have mentioned, where you can scale your requirements. You can be very elastic in terms of when you need and how much you need, kind of a thing. Okay, so this advantage makes people to take advantage of going to the cloud, right? Nowadays, hardly people runs in their own infrastructure. A lot of things are moved to the cloud. Okay, so for example, even your college mail servers, in majority of the cases, you don't want to run your mail server in your college, right? It's a big headache. You just ask Google's or somebody else to host your mail server, or just give the mail server service. Okay, but only thing you have to focus is on the network connectivity, the internet access. So once you have the network connectivity, you can take the resources from anybody. Okay, so this is just a case of, I'm just telling the different types of cloud here. So imagine somebody wants 4 GB RAM, the same example I took, 4 core with 100 GB hard disk with 1 gigabits per second. So if somebody wants these resources from my laptop or my server, my job is to provide them these resources and nothing else. So what they do with this resource, it's their problem. Okay, they can install whatever operating system on that they want. They can install any application on that they want. I will not interfere in that point. Okay, so this is what typically people refer as infrastructure as a service. Okay, where I've just provided the infrastructure to them. What OS, what application is running, everything is left to the user of the infrastructure. Okay, or if somebody wants, taking example of AA here. So if somebody wants to do a C or Python programming, so they will just ask me, hey, give me a Linux operating system with an editor and compilers and interpreters all installed in it. Okay, I will write a program. Okay, so I will write a program. I'm good at writing program, but you give me a resource with whatever with the RAM. I can ask for the RAM and cores and other things, but I will also ask Linux of what operating system and what all compilers and editors I need. Right? I don't control the underlying hardware now. The underlying hardware is controlled by the person who is providing. So the underlying hardware management is not the problem of AA. It's a problem of the person who is providing this service. So this kind of service is called as PaaS, or platform as a service. Okay, where you don't talk in terms of the infrastructure resources, you talk in terms of the platform that you would want to work on. And finally, another thing is, imagine that AA has started a company and they would want a mail server to be running on it. Okay, so whether you run it on a Windows or a Linux or any operating system, they don't care. And what kind of application you are running, SMTP or any kind of application mail server running, they don't care. They just need a mail service thing. Okay, so this is where software as a service comes into picture. So everything below the software, the platform, the hardware, the user should not bother. Everything is the headache of the service provider. Okay, so this is where the three services, which is pretty common. There are other services, I don't want to get in there now, but these three services are very easy to understand and very common in the cloud world. So this aspect is what differentiates the security. So hello, was there a question or
Sorry, sir. Sorry. By mistake, it has been.
no problem. No problem. No problem. So we have now IAS, PAS, and SAS thing. So is this aspect clear? Because it has to be very clear on IAS, PAS, and SAS for you to understand the security aspects of this one. Like who will be responsible for what? Yeah, go ahead, Ajay. Yeah, go ahead. You can ask the question. Hello. Somebody raised a question. Okay. And there are somebody in waiting. Should we allow them or how is it? I don't know. Anyway, I'll continue on this thing. So these aspects are very fundamental, and this is where we rely on in going ahead in our session. Okay. So anybody, they had a three option, either to buy a laptop or use my laptop or do both, right? So if they do, but for them to decide which option to go, whether to buy a laptop or use my laptop or do both, they have to decide on what kind of application they are running. Okay, so at the end of the day, the very, very, very important question is what kind of application I'm running and where do I want to run that? Okay, so for example, if they want a web server or a website, anything, and if they want a mail server, and if they have a products called XYZ or ABC, so if we have these multiple software products that they have, they can decide whether to run on their own server or they want to use someone else's server or kind of do both. Okay, so how do they decide? There are, again, we decide on the various factors that are there, the usage, cost of maintenance, the skill set they have. So they consider all these aspects and decide which of the option to take among those three. Okay, but this is the most important question in the cloud, right? Where does my application reside? Okay, so my request is, if you are new to the cloud domain, you should, this is the very, very, even in that case, you should always ask this question. Any application, even for example, if you pick your mobile phone and look at this application, the first question you should be asking is, where does this application reside? Okay, for example, your majority of your, in your mobile phone, majority of your application resides on cloud, right? There are hardly very, very, very few applications that actually resides on the system. Majority of them resides on the cloud. Okay, so you have to answer this question, where does my application reside? I think. Okay, so see, how do I remove this notification? Okay. So if they want to run everything on the server, on their own servers, they will have to maintain everything, but they will have a full control, right? But they will have to maintain all the things that they have, and they will have to, and they can use for their own usage, but it will be usually called as on-premise. Okay. For example, in your college, if you are running some application within the campus of your thing, this is the use case of that. So if you have a private So this is what the term called private cloud comes into picture. So if you set up a bunch of servers in your college and run some applications within your campus itself, so this is what is called as private cloud. So all your application resides on premise. So some of the examples in college, typically what I have seen is the Moodle, right? Many colleges run Moodle within their infrastructure, whether it's managed by a data center infrastructure or any infrastructure, they run it on premise use case. So that is where usually they run it in their private cloud, right? But in some cases, they don't want to run. Why do I get this notification? Okay. So, but if they use my server or the cloud provider servers, because it helps them to go to the public cloud. So that is where, for example, in many colleges, right nowadays, they take the help of Google for the mail service. Okay, so they'll be using in that case the public cloud. And today now we have Google, Amazon, Alibaba, DigitalOcean, a lot of these kind of high-end cloud providers are there. You name a service, you can just get it from these providers. Okay, but there are some use cases where they would want to do both private and public cloud. That is when it's called as hybrid cloud. Okay, so for some part of the thing they would want to run in their private, and the rest they want to run in the public, and they do the exchange between these two. That is typically referred to as hybrid cloud. Okay, so this is a quick summary of cloud. So I just want to recap till now what you have seen. You have seen what is basically a cloud, what are the kind of services that they are offering in the cloud, IaaS, PaaS, and SaaS, and what are the different types of cloud that we see in this. Okay, so in telco use cases, right, in majority of the telcos, it's always mostly the private cloud. Okay, they rarely go to the public cloud, mostly because of the security and the performance reasons. And in majority of the use cases, they stick to the private cloud. And at the max, they may do the hybrid option, but in majority of the cases, they do the private cloud itself. Right. So I will skip this aspect of virtualization that will help you actually to achieve these things. But you just have to remember that if you want to achieve this across thousands of servers, you need something called a virtual infrastructure manager, and OpenStack is one of such virtual infrastructure. So again, please don't forget whenever you use the resource. In this case, we usually refer to compute, storage, and network. Okay, so. And typically, this is how you would have seen if you have not seen any data centers and thing. Typically, there'll be a kind of a rack server or a blade servers, and they get placed in these setups called racks, because I'll be using these terms racks and pods going ahead. So these are all the racks that get placed, and there'll be a bunch of racks, maybe a 9 to 12 racks placed in what we call it as a pod. Okay, so if you have heard across the terms, these racks and pods, this is how they kind of look. And all these racks and pods get placed in a large buildings, which is basically a large scale data centers. So these are how the large scale data centers kind of look. They'll be like 10 times bigger than the football field kind of thing. And these are the pictures of the Google's cloud. So when they made the images of their cloud public, it created a really awesome experience for a lot of people who were not aware of how Google is running the cloud, right? But this is the cleanest I have seen in India, especially with the telcos. That where I work in some of the telcos thing. This is actually the picture from one of my work environment in the cloud thing. It will not look like what you see in the Googles, but it's the closest that we can get here. Okay, but it takes some more time. But of course, enterprises clouds are way more better than the telco clouds yet. Okay, so any question till now? I will just quickly summarize the the telco trend that's happening before we move on to the security aspects only. Okay, so hearing none, let me continue.
Excuse me.
Yeah.
Sir, can I ask a question?
Oh, go ahead, please.
You are mentioning about telco cloud and enterprise cloud. So if I am correct, telco cloud is enterprise cloud is like the AWS or Google Cloud or Microsoft Azure. So can you give a few examples for telco clouds?
Yeah, I'll come to that point. So here the term the telco cloud or enterprise cloud refers to the cloud. The idea is the same. So there is no difference thing. What examples you gave was a public cloud examples. Okay. So on that public cloud, whether if you run enterprise applications, that is usually referred to as enterprise cloud. Okay. But if you run a telco applications, that is usually referred to as telco. So what kind of applications you are running is what that matters. Okay. You got my point. So it depends on what kind of applications you are running. If you are running applications like a banking applications or any of the majority enterprise applications, it refers to that enterprise cloud. Whereas if you run a telco application, it will telco cloud. Now, what is this telco application? I will come to this point now. Okay.
Sir, kindly please speak to serial number 173 to mute and turn off their video.
Yeah, thanks. I think it was Anthony, right? Thank you very much, Anthony. Okay. Yeah, 173. If you can turn off the video, I think, yeah, thanks. And is there a way to get rid of this notification? Okay. So anyway, how do I get? Okay. So quickly, I will explain the trend in telcos that is happening, right? See, telcos, right? They are predominantly, maybe until past 4 or 5 years, even in fact, in many telcos, even until past 1 year or so, they were fully into boxes. Okay, they can only understand boxes. If they want any service, they will just order a box from Cisco's or Juniper's or in Nokia or Samsung, any of these guys. Okay, so they were known for buying the boxes. They always used to deal with boxes, and software was an alien word for them. Okay, they hardly anybody worked in software in telcos, I think. Okay, but this changed maybe 5 years back when the concept of virtualization came. Whatever it was in the cloud, in the enterprise domain, which was very popular in the cloud thing, came to the telcos, right? So that is what that when that entered to these telcos, changed the whole thing, right? A lot of people were initially hesitant to move to that. Can somebody go to the mute? Yeah. So quite a few telcos were hesitant to move to that, adapt the new approach, but eventually they had to do that thing. Okay. So if you see, especially in 4G state in India, right? When it comes to the availability and when it comes to the speed, we are not really there yet compared to the other countries. Even if you compare to the thing, we are even the speed is almost like still around 6 Mbps thing, and we are actually 1/7 of the fastest 4G speed that is there. Okay, So if you see in this availability, though we are at a very high when it comes to the availability, but when it comes to the speed, right, we are almost in the bottom there. So if you see, we are somewhere here. Okay, so this and this is going to change because they have to adapt to the virtualization trend that has happened throughout the world. Okay, so one big change, as I said, is what is called as network functions. Whatever the network functions, right, they all getting virtualized. When I say virtualized, what do I mean by that? So as I said, telcos are known for buying boxes, right? So if they want a firewall, if they want a CDN or a DPI, any router or anything, they just used to order boxes. Okay. Now the idea was to, hey, why don't we take, instead of buying a new box whenever I want a new service, why can't I virtualize it? And that means run the same network function on a VM virtual machine in a cloud. Okay. So all these network functions, which are actually the network function, the routing, the switching, the VPN, the deep packet inspection, the firewall, they're all classic network functions, NAT, all the EPC, any telco for 4G services, all those network functions, they were all kind of virtualized or maybe taken and run as the software on any virtual machines in the cloud, right? So that very, very important change in trend happened maybe only like 4 or 5 years back in thing. That's what people refer to as NFV. So if you have not heard of this term NFV, that's what basically it means. Whatever they used to run in the boxes, now they are kind of moved to run on virtual machines in the cloud. Okay, so this migration from boxes to running inside a box to a virtual machine changed the whole sector itself, the whole domain. Previously, all these boxes were owned by networking companies, right? Now, any company, or there will be so many companies that came up who were not at all into networking, they came into networking. Because for them now, they don't have to build a custom box, right? There's already a server which is available commercial, it's off the shelf, you can buy the server and you can just run it on that server, that's all. You don't have to build any custom box nowadays. And in fact, nobody goes and buys these kind of custom boxes thing, because you can easily remove the vendor lock-in. So even the people who used to make these boxes, they have to give their, they are also selling the virtual machines now. Okay, so you don't buy our box, you just buy a virtual machine and you can run in any cloud that you want. Okay, so this is a very, very important aspect which made all these telcos to become, to behave or start behaving like a cloud providers or Amazons or Googles, or to get into the software domain, right? So in fact, AT&T, what they did was they almost 3 or 4 years back, they sent almost 25,000 of their employees back to university. So Georgia Tech and other university, they had a tie-up thing, and they trained 25,000 people in AT&T in software development. Okay. Yeah. Hi, Santosh. You have any?
Yeah. Hello, sir. Good afternoon.
Good afternoon. Yeah.
As you mentioned in the earlier slide, there's a last point, SDN, software defined networking.
Yeah.
SDN, network function virtualization, will be the game changer.
Yeah.
So will you think that in India, because we are not aware about the SDN technology, means in India, I don't know how much work is going on, but outside countries, they have already implemented software defined networking, and then they are using the network virtually. And likewise, you've shown this diagram that everything is going now virtually. So do you think that India will adopt this SDN technology? And be the, as you said, the change maker, or we will see the change into the existing network on the
Of course.
slide that you shown.
Of course, of course. So one of the earliest adapter in India is Jio. So they are now almost a lot of parts of their network are virtualized. Okay.
Yes.
They're already like a 40% of their whole network they have virtualized.
Yeah.
So now next second in this thing is a Vodafone. Okay.
Yes.
So Vodafone maybe like a 20% of their network they already virtualized. In fact, there are no other option. So this is not an option. I will come to that point why this is not an option and how this is helping both Jio and Vodafone and even Airtel. Airtel, I'm very surprising. The Airtel is slowest among all the three. Okay, so they behave like a government company for some reason, I don't know, but they are very slow in compared to other two players when it comes to virtualization. Thing. So the image that I showed, right, this is one from the Indian telcos itself. So this one. So they are already adopted, in fact. What they
point is here that apart from the telco industry, why not the industries, the small scale industries, they are adopting the SDN? Why the Indian means? I don't want to blame here. Why this technology has not adapted too much? Because in the outside country, if you see that 5G is already implemented and SDN is incorporated with the 5G. And even if you see the change in the Indian companies and telco companies, only Jio, if a few companies are adopting the technology. So I'm just asking that whether it is going to adapt all or at the small and large scale industries as well.
See, these telcos, right? Let me explain that and answer the question. Traditionally, the telcos focused only on providing the connectivity services. Okay, when I say connectivity means you used to use telcos in like Airtels and Jios only for connectivity purposes, whether it is wireless or wired connectivity.
Yes.
So a lot of companies on top of the telcos, they used to run services. So they used to make money on top of the telco connectivity.
Okay.
So a lot of cloud providers or many of these cloud providers, they provided service on top of these telcos and they used to make money. Now the telcos have realized, hey, on top of our connectivity services, they are making money. And sometimes we are paying them itself for using our own connectivity. So that is when they said, no, we're not going to do anything like that. Now we are not providing only connectivity services in future. If we are providing only connectivity services in future, we are gone. Okay, so that is when they decided to adopt this virtualization thing and start virtualizing all those things and create a lot of clouds throughout the India. So today, if you see Geos and Vodafones, they have at least like 100 to 200 clouds that are running throughout India. Okay, now they want to offer these cloud service also to any industries. So they are behaving like Googles and Amazons in India, right? So that is where if you see Geo also their businesses thing, now they can host. They're providing hosting services.
Yes.
Host in Geo. They're also providing what is it? Commercial e-tail services also to it. So all of things are running on top of their connectivity now. So now they are not losing, providing only connectivity and losing out any of this business thing. So they have to provide additional services along with connectivity. So if this virtualization is done only for connectivity, they cannot survive. So the whole change in trend, why they had to adapt this is because they can provide additional services on top of this. So the mantra is services.
Yes. Got it, sir. Got it. Thank you, sir.
Yeah. Okay. So so this is this. Let me. Yeah. So this is what typically the term NFV is thing. So basically, it's called as cloudifying the network services. So whatever the network services that were running in boxes, now they are running in cloud now. When I say running in cloud, please take it as running as a virtual machines on one of these servers. So they replace whatever the physical boxes they saw. I already explained these things. So the moving the functions from whatever traditionally in the boxes thing and run in standard servers. Okay, so this has helped the whole business itself has changed. A lot of there is no vendor integration at all nowadays with the telcos. They are not dependent only on Cisco's and Junipers, for example, for networking services. So, for example, the white boxing, the servers, right? Traditionally, all these big servers which I just showed in the picture, they were all provided by Dells and HPs, right? But in Google, maybe when in 4 or 5 years, when they made it public, they used white box switches. That means there is no brand on it. So they directly dealt with the end original equipment manufacturers in Taiwan and other things, and they got it and they're just managing with that. So that kind of had a huge impact on these branded services also. So today, if you want to buy a server, there are so many options you have now, right? So all these telcos now, there is no vendor lock-in, and they're gonna keep in the business ever more changing the business things. So this is an example where a complete EPC basically is the 4G technology. It's basically used in LTE. It's a part of an LTE. I will not get into that proper telco 3GPP descriptions. For your simple understanding, it's basically a collection of services that constitutes your 4G connectivity thing. Okay, so all of them, they are running as a bunch of virtual machines on a server. Okay, so for your understanding, you just have to say that you will have like hundreds of servers. In each of the servers, there will be 2 to 3 virtual machines, and in each of these virtual machines, these kind of network functions are running. Okay, yeah, I don't know. Let me move it. Okay, so now initially, typically, if you see the telco growth thing, they were focused mainly on the providing the connectivity services. When they added more and more data also, initially, if you know, it was started with voice, and then you added the data services. Now with new 5G coming up in thing, everything is moved to the services, various other services that can offer. So typically 5G refers all these kind of services for factory automation, smart grid, the virtual reality, the IoT is the hottest among all of these services that have been added in. And even in India, a lot of things will start with IoT itself. Or maybe what is it, smart traffic management. All our smart cities should take advantage of 5G services that the Indian telcos will be providing. Right. So their main, this Jio's and Vodafone India's, their main goal will be on providing these services. So don't be surprised. That's what you would have seen the investment that's also happening on Jio. Facebook is invested in Jio, right? Because they can push their services to easily along with Jio. Okay. Maybe I will move. I don't know, how do I move this? Can I hide this thing anyway? Hide floating. Yeah, good. Okay, so this is just a reference architecture. This is for you to easily understand the things that will come on. Okay, so oh man. Is it because people are waiting in the waiting room and that's why it is showing regularly, or? Okay, so in this this box, the below blue box, right? So this is your bunch of your resources, physical resources, and they are virtualized them, compute, network, and storage. So for your understanding, think of this as bunch of all those racks that you saw. Okay, so these are all the physical and resources that have been virtualized as set of VMs here, right? And on top of this hardware, you run your network functions. Okay. So on top of this hardware, you run your network functions that are running on top of this hardware. And all of this hardware is managed by a infrastructure manager kind of a thing. And also all of this workload, the network functions are managed by, again, a workload manager. You can think of, for example, all these things, right? It could be a router, it could be a firewall, it could be a data deep packet inspection, all these kind of network functions. Okay, so this is a network function manager. That's why it's called a virtualized network function manager. Okay, and both of them usually send all the data to the operations, network operations team in a separate environment. So this is the high level architecture thing. Okay, so this is OSS BSS is typically the telco's term for operation management and business management. For your very simplified understanding, whenever you go to a Airtel website or a Vodafone website, that first website that you see, you can, for all your practical reasons, for your simplified understanding, that is the BSS kind of thing. So that's where all your trigger starts thing. Okay, so please let me know if you have any question in this understanding this picture and how to visualize this picture in a real world sense. Okay, so this will be the whole thing will be hosted in a single data center kind of environment, and each data center might run a bunch of network functions in it. Okay, and that will be connected to the operations environment situated in any way. Maybe I will just use a empty slide to explain this thing. Yeah, hi. Priyanshu Srivastava. You have any question?
Sir, I am not able to visualize this in real world scenario because I'm not seeing any data center itself.
Okay, so this is an example of data center, how it typically looks. This is a classic example, I think. So as I said, for you to visualize the servers, right? So these are the servers, individual servers. Okay, and these are the racks that are there in the servers. Okay, once you put all these servers inside these racks, and all those racks are put into a big box called pods. Okay, and in each data center, you will see these kind of pods that are laid like this. Okay, and in each of these servers, you run virtual machines. So for all your practical reasons, when I gave explaining about the cloud, this could be like a laptop for you, right? That's why I tried to use the word laptop, but this is a server basically. Basically, it's the same thing, but it has large amount of resources compared to your laptop. It will have 256 of RAMs, maybe 88 cores, sometimes 60 to 80 terabytes of storage, this kind of thing. Can somebody please go to mute? Rajeshwari, please mute. Okay. Okay. So just for you to understand how the in real thing that's happening, right? You have heard of word exchange, telephone exchanges, right? In those days, they used to have these telephone exchanges, right? Oh, can somebody?
If host can mute all the participants, if they want to ask, they will ask the question because they are interrupting. Many of the participants have unmuted and they are listening to the session.
So please open the chat box and then unmute all.
Okay, thanks. Okay, so you would have heard of the term called telephone. telephone exchanges, right? Man, maybe I can mute Rajeshwari. Mute. Yeah. I'm sorry, guys. I have to mute. It, okay. Yeah, wait. So we have this in India, especially. We had this term called telephone exchange that we used to refer. Now, all these telephone exchanges, right? They have been converted into data centers. Okay. So let me use something to explain this term. So if you what is this? Yeah. Okay. Okay. So these telephone exchanges, right? Exchanges as data centers. Okay. So let me give you a high overview of the flow that can happen thing. So for I will put a data center as a big box kind of a thing. So this, for your practical visualization, you can think of it as a building in nearby, or maybe a floor or 2 floors in a building. Typically, that's how you we will see in exchange nowadays. And some of the smaller data centers are just Geos and Vodafones would have rented 2 or 3 floors in a building, or 2 or 3 floors in a building, 2 to 3 floors in a building. Okay, so typically what the flow happens is you have your user set or a mobile phone. For example, let me take an example of mobile network. Okay, I think maybe you will be familiar with some terms. So you will have a mobile end user. So end user is using a mobile. Okay, so I'll just put as an end user. So the first connectivity he will of course connect is your the antenna. I'm just putting some boxes because I don't have the actual images thing. So your antennas, right, which is the nearest antenna, and this nearest thing is your E-node Bs. So if you're not familiar with this term, don't worry. This is the kind of a first component that will receive all your connectivity with the end user. So this is the wireless connectivity, right? I don't know. I used to use some term. Yeah. So I'll just put this to indicate that this is the wireless connectivity. Okay. So from E-node B, typically it will be connected to a component called S gateway or P gateway kind of thing. Okay. S gateway and P gateway. Again, don't worry about what if you don't understand what is this as gateway and P gateway. These are all part of the telecom network, 4G network or LTE network, if you have heard of it. I'm removing some of the components which will help to identify the user, what is his phone number, whether he is registered with us, and all those components are not required. I'm only focusing on the data flow, right? So from there, it can go to some GI services. It's called this typically GI service. I'll just put it as a GI services. So it will include a firewall and other things. And also your IMS voice connectivity, voice support, and all those things. And finally, it goes to the internet service, internet thing. Okay, I don't know where I will. Yeah, I'll just put it as a internet. So backend network, backend or backend. Okay, or it could be just the internet. Okay, so typically the flow from the user, whenever you make a call or you do mobile access, internet access, the flow will be typically like this. Okay, so it can go like this from antenna, from your thing to the antenna to the E node B to the S gateway, P gateway, from there to your GI services, and finally this thing to backend. Okay. Now imagine this will be connected from here. There'll be a wired connectivity to your building, to this building first. Okay, so this S gateway and P gateway is implemented in one data center. Okay, so I'll call this data center 1. Data center 1. So this, all this from the mobile, it comes to one building. Okay, then the another thing might be implemented in the same building, or it could be in a separate building also, data center 2, where all your GI services might be implemented. Okay, so in such cases, it might go to the backend network and come to the thing. So for now, let me say I will implement everything in the same building. Okay, both GI services and the thing are implemented in the same building. Okay, just for the reference, I'm just giving as an example. So I haven't, I'm sorry, I haven't started the security yet, and we are already an hour. Anyway, so the packet will, the data will, when the mobile make a call, it comes to the antenna, it goes through your data center building, and from there it can go to the either the internet or the backend, telecom backend network, right? So it can go to the internet. There'll be one to the internet and there'll be one to the backend network. So this backend basically is to connect to the other parts of the telecoms throughout countrywide network, right? So every telecom, you can just Google for BSNL India-wide network thing, right? You will see how the you can maybe BSNL India network architecture or something like that. If you Google for images, if you see, you will see how throughout India their network is. Somebody has put in the map also. Yeah. Anyway, yeah, maybe this will, I don't know, I have a very small resolution. There are quite a few with a very large resolution. Throughout countrywide network is there with the map. Anyway, so you will find it online. Maybe, yeah. So in BSNL, they have the 5 major points, Noida, Kolkata, Mumbai, Chennai, and Bangalore. From there to various smaller points. For example, with Hyderabad, we have Bangalore to Hyderabad and Chennai to Hyderabad. So this is the second level of network, and with the blue being the third, and the smaller will be the smaller cities. So this is how the BSNL backend backbone network is. So this is what I refer to here in my backend network. Okay. Now, the flow that happens is like this. It comes to the data center and goes out of the data center. Is this clear? So whenever we say in this picture, right, the packet enters here like this. Okay, it enters here and it goes out of like this itself. Okay, so all the data, or whether it's audio or data, everything enters like this and goes out of this like this. And when it enters like this, typically what happens is it can go from one VNF to another VNF to another VNF, and then come out of like this. Okay, so typically this is what you will see kind of happening. How the flow might happen. Is this clear? So the packets enter a data center and leaves the data center like that. It passes through its different virtual machines, different VMs, and comes out of those. I think this is a very simplified understanding for you to understand the flow or what's happening in the cloud, telco cloud, basically. So this is my telco cloud, this box, right? So considering the time, I will move to the security part. Let's just take a 5-minute break. Can we take a 5-minute break? Is it okay?
Shall I ask question, or after that, after your session, shall I ask?
No, you can ask my question now. Yeah.
Nicely, sir. Nice session. You are explaining very well. If we are implementing on the existing infrastructure, likewise we have the existing infrastructure, routers, switches, and if you are using the cloud services onto the existing infrastructure virtually, so all the technologies that have geo and all, whatever the existing infrastructure we have, and if you are building the network on with the virtual, so will it provide all the services that we have right now?
Yeah. So very good question. Okay. See, see these services, these boxes, right? Before the NFV came into thing, before the virtualization came into picture, they were all separate boxes. Okay. Even today, in many parts of India, you will still see those boxes being used.
Okay.
Okay. So the idea is going ahead, people will try to get rid of all those boxes and everything will be virtualized in the data centers. Okay. And until such time, they have already invested money on the existing infrastructure, right? You won't waste that thing. Okay. So they will continue to coexist as much as possible. And for example, maybe recently we are working in one place in Goa site. There are some set of already the infrastructure is running here, and the Goa population is also increasing. So they are diverting some traffic to the data center and some over this physical infrastructure. So typically this is called as a PNF. We call it as a physical network function, PNF, and virtual network function. Okay?
Yes.
So the idea is to use some traffic over PNF and some over the VNF until you fully move to the VNF. So that is how you measure a telco, how much of virtualization they have done. When somebody tells that, hey, this telco has achieved 100% virtualization, that means they have got rid of the dependency on these boxes.
Yes.
Okay.
But the 5G, if the in the India or the telco, if they want to move for the 5G network, can they still rely on this existing network, or they have to build a separate infrastructure for the 5G network?
They can rely on a lot of things, existing ones. But when it comes to the bottleneck points, right? For example, 5G, it defines a lot of even they define some of the places they define the physical layer components specifications also for the performance side. But majority of the 5G is around services definition. So they can realize all the services components, but when it comes to the physical performances, to achieve that speed, they may have to replace, or rather they will have to replace.
Okay. Yes.
Same thing,
Yes.
similar to our, even for the end user, it happens, right? He will have to replace.
Yes.
Okay.
Sir. Yes. Thank you, sir. Thank you very much.
Sure. Hey, I'll just get some water. Can you give me a minute break? Sorry.
Yes, please.
I'll be back in a minute. Yeah. Okay. Yeah. So I hope now you have some at least a faint idea of the flow that happens and how these telephone exchanges are getting converted to data centers and how these data centers are used, how the flow happens on these things. So I will try to use this thing and continue with focus on the security part now on. Okay. So before I move on to the security, if you have any questions on telcos and the cloud, because they are the foundation. So without understanding telco and cloud well, we cannot really get into the telco cloud security part. Okay. Okay. So let's continue then. Thanks. Well, apart from being a very hardware or a box kind of people, telcos, there is a very, very strong requirement in terms of security for them, right? So telcos have a different kinds of security problems for them. There is but majority of them is mostly around operational security they focused upon, because everything was around boxes, and all these boxes were closed boxes. When I say the closed boxes means they were not like 8086 Intel processors and all those things, and there will not be a specific login and all those things for that. Majority of these boxes were closed, right? Now that you have taken those network functions out of those boxes and running as a VMs, it will expose a lot of security challenges also, right? So, and in general, whatever the cloud telcos entered the cloud domain pretty late compared to the enterprises, right? So enterprises had already were spent a lot of time in the cloud domain. They had moved, migrated to the cloud. Even universities have migrated cloud long back compared to telcos, right? So they had already fixed a lot of security challenges. In fact, over past 2 days, you would have heard a lot of talks on the security challenges, on identity management, and all those things, which applies to the cloud domain, right? So all these bankings and all those big enterprises, right, who are also pretty, very conscious about security. So they had solved a lot of problems for telcos. So they need not focus too much on those for now, especially. And only thing what is unique to this thing is what we will focus on today's session. Okay. 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 Yeah, so we have seen the three services, right? Infrastructure as a service, platform as a service, and software as a service. When it comes to the security responsibility, right, it varies across these three services. Okay, so it depends on what you are doing, whether you're doing IAS or you're doing PAS or doing SAS, your security responsibility will vary here now. Okay, so in case of infrastructure as a service, everything is left to the consumer in cloud, basically. Whereas in case of SAS, majority of the problem is with respect to the provider, right? For example, if you're taking Google's service, email service, right? All the security aspects, whether in the hardware security, all those things are all managed by Google. You never bother about anything, right? But if you have taken infrastructure from Google, instead of buying email service, right? If you have taken, for example, 4 GB RAM and 4 cores with Google, now the operating system security, the application security, platform security, everything will fall under you, right? So depending on the kind of services that you are taking from the cloud, that's what defines how much of responsibility you have in this case. And as I said in the beginning, in telco's case, right, everything is there. They are mostly on IaaS kind of a thing, and also they mostly run as a private cloud. So all those all the security issues are their own problems now. Okay. For example, if you are seen in Google, when you take when you take control from, when you're trying to purchase something, services from them, they neatly tell what is your problem and what is their problem. Okay. For example, if you take an email services thing, the email content and email access and how much of usage is your problem. Rest all is Google's problem. Or if you take the infrastructure from Google, all the network security, the operating system security, access, identity, web application security, all the security is your problem. Google's problem is very less, right? So this aspect of responsibility from the provider to the consumer and service specific is what differentiates cloud security. Okay, so when somebody refers to the term cloud security, you should really first answer what kind of services are we talking about? Is it an infrastructure as a service or a platform as a service or a software as a service? Okay, so if you're talking about IaaS, right, the provider of that cloud has very, very minimal per headache. It's everything left to the consumer of the cloud. Okay, whereas if it is a platform software as a service, the provider of the cloud will have all the responsibility, whereas the consumer has a very minimal responsibility. Is it okay? So this aspect you should try to remember. It depends on what kind of service type you are talking about. Okay, and why this? Yeah, so as I said, in case of telcos, right, because it's a private cloud and infrastructure as a service thing, and he has to manage both the workloads and the infrastructure. There are mainly 8 categories that these telcos have to handle in terms of security. Of course, first is the infrastructure security. Whatever the servers and everything they buy to manage them and secure them is what it's their headache. Here it also includes the operating system security. Right. So in parallel, I'll just highlight some of the standards or specifications that has been enforced, and these telcos have to meet those specifications. Okay. So just for your reference, I'm just adding the specifications and standards also along with this slide. Okay. And it also includes the platform security and also the network security. So these are all the standards that comes under the network security and the platform security. But you will be surprised to see how many of them are there in this standards. It's really a big pain actually. And the next is basically the application security, or all the network functions that have been virtualized and running on the cloud. That's their application security. In telcos use cases, all these applications are network functions. Okay, so typically these are all the standards that is more or less it will cover for majority of the applications thing, but it applies, the same thing applies to even for the telcos use cases. Okay, and the next is the data encryption security and the encryption. Because a lot of issues, there'll be a lot of user specific data thing, and there'll be a lot of requirements around the security and encryption thing. So these are all the standards when it comes to the data encryption, whether it's a control or in motion or the encryption. Maybe you would have come across these standards, or maybe somebody else would have covered in the previous sessions already. So if I'm repeating these things, please forgive me. And the identity, entitlement, and access management. I know that for sure on Monday, one of my good friend Lakshmi Narayan had covered this topic, identity, I think. And I'm sure he would have covered some of these specifications also on the identity and management. Even in telco cloud use case, we have the same problem of using identity and entitlement and management. And incident response. So this is much more serious in terms of telco use cases. When in my personal experience, we hardly get few, like a 2 hours, starting from 10 minutes to 4 hours kind of a thing for any kind of incident that to address it. or else we will have to forego all the business. So interestingly, in Japan, they don't charge for spectrum like we do in India, where we auction the spectrum and sell to the telcos, right? The government not charges much for the spectrum, but they charge very heavily if the services go down, right? So these telcos in Japan have a bigger problem of ensuring that the services to the user is always good. So I thought that's a very good idea, and even our government should be focusing more on that rather than auctioning and introducing corruption in spectrum auction. So next is, of course, the information governance, and we have quite a few specifications on information governance, and I'm sure it was already covered in the previous session. Compliance and audit management. So this is where it's very big compared to other enterprises clouds that you have seen in telcos. It is a very big issue for these telcos, and these they have to at least comply to these three things. Mostly on the ISO 27717 is more or less the everybody has to kind of be certified. And in telcos use cases, right, it will always be audited by the third party like Deloitte or EYL. These kind of companies do the auditing. And finally, the legal issues and contracts thing. So this was not an issue until maybe a year or so, when the telcos had never focused to share their data center for their customer, right? For example, today I am Vodafone's customer only for my mobile and data. Imagine tomorrow I will become their customer for hosting my web page hosting services or my website hosting services, right? So that will happen. That will definitely happen for sure, because they are also becoming the Googles and Amazons. So you can they will start offering the services of hosting, web hosting thing for me, and I will be their customer even for the web hosting services. So in that case, all these contracts, legal issues and contracts will come into picture for these telcos, and they had not bothered until a year or so. Now with telcos are also providing the cloud services for their customers now, just like Google and Amazon and DigitalOcean. They will have to ensure these various legal issues or compliance issues, or what is it called, service assurance. Thanks. Okay. So these are the main 8 categories of security that in telcos that we focus in the cloud, telco cloud. So let me explain that with the flow that we have seen till now. Okay, so if you remember, we had a platform. So if you remember this picture on my right side, I will try to use that picture to explain the security controls in telco. So if we have the platform, and I told you that this platform refers to this blue boxes, set of servers, bunch of servers with virtualization done on it with compute, network, and storage as the resources, right? And on top of this platform is where we run our workloads. The workloads are basically the network functions, virtualized network functions that are running on this particular platform. That maps to my this VNF boxes here, right? Now this platform, and this is what it's working fine. All the packets are entering the platform, going to the workload, and going out of the platform, right? So this flow is what I explained. I think it goes like this, right? So this is the high level flow of the data that enters to the platform, goes to the workload, comes out of the platform like this. Okay, and this platform now has to interface with one is whatever it is entering and coming out. Maybe I can put it in the right hand side thing, and also the monitoring part of this thing. So this backend networks is what that connects to the operations team. So this is your, on the rightmost side on the small blocks is my operations team. So this backend network maps to this link between my whole data center to the operations team. So this operations team just try to keep track of this whole platform and workload. What's happening in this one? Is something wrong is happening? Is everything is fine? So they are the ones which you will see, you would have seen in a lot of places with hundreds of monitors monitoring what's happening on that, right? So this is the command center, control and command center or operation center that we call. So the backend networks connect to that. And front-end networks is what all the my antennas and that eNode Bs get connected and packets enter through this one like this. Okay, so from the previous flow, as I explained, you can see that all the data coming through these front-end networks, going through the workloads and coming out of thing like this. Forgive me for this horrible drawing thing. Maybe let me try again. Okay. Not bad. It's okay. I'll just stick to this. I don't know which color. I'll use a black. It's easy. Okay. So this is maybe you can imagine there are hundreds of antennas throughout the city in your locality thing, and all from all those antennas, all the data from the mobile user thing, that it enters through my data center here, goes through the workload, the network functions. So these are all the network functions. Okay, and it goes out of the network like this. Now, with this as a setup, I think, right, the security controls, these are all the main security issues, the points of controls that happen mainly. So I will just redraw the same thing here. So it kind of comes here, goes here. Okay, so this could be kind of a one flow. Okay, and whatever is happening, this is being managed by this managed controls. Okay, so let me remove that point. Now the same thing, whatever I showed here, I'm just showing here, but to highlight the point of the issues that security people have to focus in this flow. Okay, the first and foremost is so this right hand side is an untrusted part. We cannot trust them because anybody can try to hack my this building, right? So this is my untrusted part, whereas this is the trusted part. Okay, so try to see this as untrusted thing. So any malicious thing that is happening, that has to happen from here. So this is where the front-end access control will happen. You will run a firewall in this case to manage the access thing, and once it then it will decide whether tenant access control, whether this particular user is allowed to access this network or not. So once it is okay, then it goes to the workload. It could be a router, or it could be your S gateway or P gateway, and it comes out of it and then goes out of this network. So whatever is happening, it is managed through this management access controls. Okay, so then this whole thing is monitored and managed by this operations team. Okay, so and the same thing applies to you have to multiple times of thousands of data centers throughout the country. Okay, so in this whole path, when the moment it enters, and before it goes to the workload, and after it goes to the workload, before it goes to the their backend network, basically. Of course, if it is going to the internet, that's okay. But if it's going to the backend network, it has to be checked again. So these points of controls are more important to understand. Yeah. So maybe I'll move on to, yeah. So in the platform part, right? So all these telcos ensure that these HPs and Dells or whoever they provide the servers thing, and the network switches like Junipers and Cisco's in the data center, they all have to be certified by that certification which we previously saw in the previous thing. And they will have to implement these access controls that we just showed thing for the administrators to it. So in case of servers thing, right? So they will have to support the kind of ILO configuration or IPMI configuration support on their servers and to access controls for the administrators. And this is also API for those tenants for these particular platform, whether it's switches or the servers, they should expose a standard set of APIs, and it should be secured. Again, remember in the platform here, we are mostly referring to the servers and the switches. Okay, and encryption of all the external and control communications that we just saw. And we see that it has to ensure across multiple tenants that are using the same resources. Okay, this is okay. Software update also especially in this telcos environment, right? It's all this software version update. It's a huge issue there. You have to follow a very, very strict process when it wants to update even a smallest piece of software that happens. Let me minimize. Yeah, whereas the workload thing, and if you maybe just for your understanding, in platform, right, it is not usually a single vendor. As I gave you an example, it could be, for example, a combination of a hardware vendor will be one, server vendor will be one guy, there'll be a switch vendor will be another person, there'll be a SDN solution could be a third vendor, the operating system for these servers could be a fourth vendor. So within the platform, there will be a multiple vendors. Okay. And also for these workloads, right? Now the telcos will not buy workload or the network function from the same vendor. They'll buy one from Nokia, one from Ericsson, one from Samsung. So it doesn't matter. So that has given them the flexibility which they never had before. Earlier, they had to buy this from the same vendor, all the boxes. Now they can, they have the freedom to buy virtual machines from different vendors. Okay. And each workload network will need to undertake its own security assessment and accreditation. And it has to pass the workload security certification, which I just showed before. And the service activation on each of these network functions should also be automated, and it has to go through that secured automation. So he owns the complete security certification process, the workload security and the platform security certification happens separately, and they are managed and audited separately in kinds of telcos. So maybe I could show a huge form. It's there are almost like 200 rows in that particular form for us to complete the security checking in both platform and in terms of workloads. So each and every controls and processes, the calls, everything is managed in this case. And workload owner also has to own the design changes. So if you see in this telco use case.
Hello.
Hello.
Can I interrupt you, sir, in between?
Sure.
Just now you have shown us the telco management system for access management and control management with the PNF and physical network as well as virtual network. Correct. I just want to know, because the virtual service is instance based, right? So which are the softwares the telco is having to manage the network? Because this is not just for the simple platform, simple workload. It is having all the platforms like software and then infrastructure, everything, application, everything. Then which are the softwares telco owns for management techniques? They have their own setups, or there is collaboration between the service vendors and all. How they manage this? This is very complex because security in
Correct.
the cloud is instance based, because it is just for a second someone may use the service.
Correct.
So,
Yeah. So when it comes to the what kind of tools and software that they use for this management, right? It depends on at a broad, very high level, you can focus mostly on the workload and the platform. So the workload is very vendor specific, because, for example, this could be from Ericsson and this could be from Nokia and this could be from Samsung. Okay, and they are bound to provide the tools along with their VNFs for, or if they don't provide the tools, they have to provide the APIs for the telco to access these VNFs to check for the security thing. Okay, but whereas when it comes to the platform, right? So this is where it is very generic. Okay, so what are the tools that are used in platform? When I say platform, again, I include both the servers and the networking switches also. So the fabric, what we call typically. So typically in all the data centers, the switches are mostly in a leaf and spine configuration thing. So that platform security is what they keep it generic. So that will not be very vendor specific things. So I will, when I talk for this platform thing, right, there are two aspects thing. So maybe I will just use a slide to type it here. Okay. So one is security hardening. Okay. And security monitoring. Okay. So when it comes to hardening, there are a bunch of tools to harden each and every component. Okay, and this is for monitoring. There are both commercial and open source tools. Okay, telco initially started with commercial tools, whereas as and when in over past year or so, open source has dominated the monitoring part. But when it comes to the
sir, can you name the open source?
that I will come to that point. I have a separate slide for that. I will come to that point.
Okay, sir.
So for each and every aspect of this thing I showed here, right, I will show you what kind of open source that you can use and you can work in your as part of your research activity.
Okay, sir.
Okay, but when it comes to the operations thing, which will the operations team, right? So they are the ones who will receive all this monitoring and management data, and they try to do some analysis and maybe I'll just minimize. Yeah. So in the operations, right? So in the operations team, so this is again a separate team who will, so they will receive all this data. So they receive all these alerts, alarms, metrics, logs from the platform and the workload. So they receive all these things from both platform and workload. Okay, so we will keep it to only to these two as a mainly thing. Now these once these operations receive it to manage. Basically, in this case, manage is basically store and organize thing, and visualize. Store, organize, and visualize. Organize, visualize, and analyze. So this is for this purpose they use mostly commercial tools. But nowadays the trend is the analytics part, right? So this is where in the analytics part, lot of open sources have playing a huge role when it comes to the analytics of telco data, right? So analytics of telco cloud data rather, yeah. So this is one of the very, very interesting research domain if you are interested in applying machine learning to telecom cloud, this is the domain. But here the open source are dominating.
Okay, sir. Thank you very much.
Okay. I was here. Yeah. So this is where the VNF vendor. This is VNF means the network function vendor. So his responsibility is basically the workload. That's what I have been referring to, workload. Yeah. So his responsibility is his operating system that he is bringing for the virtual machine, securing that one. Nowadays, over past 6 months, the trend is go more towards moving from virtual machine to containers, right? I think you may be aware, containerization is much more recent trend, and that also applies to the telcos. So telcos are moving to containerization. That's happening already. A lot of things that were running as a virtual machines, now they are moving to containers. So the application security, they securing the network interfaces and the management controller. So the vendor of the VNF, the workload vendor, that is his responsibility in this case. And whereas the operator responsibility, as I said, it's mostly around the platform. Where is that? This is somehow making a lot of nuisance. So when it comes to the operator, he has to ensure mostly around the platform, the hypervisor that is running on each and every servers, the VM and container management that happens, management system, the APIs, the network interfaces, the networking security zoning, the platform patching each and every platform, the upgrades and thing, and finally the regulatory compliance. So this is what the telco mostly focus. He will stick to the platform and he will move the responsibility of workload to the VNF vendor. Okay. So this is where the platform provider, whoever is the vendor who is providing the platform, he mostly focus at a very higher level rather than the actual processing. So we can skip. So I have 2 more things to share. Let me take a quick look at the time. I have like another 18 minutes or so. I wanted to cover 2 more things. One is on the, let me first cover the open sources, then I will come to the part. Okay. So what are the open source tools for the cloud security? So this is more generic for the cloud security, and we also use it in the telco cloud. Okay. So the first is not so the Linux version itself, right? So some of the very, very secure thing that people wants to use is Kali Linux thing. So if you haven't heard or used of Kali Linux, telcos are not using this one. They use the mostly Red Hat's RHEL kind of a thing. They guarantee whatever the Kali Linux provides the tools, they also add it in this thing. So, but what is more important is the tool that comes with it. For example, these two are used in many telco environment. So AIDE, if you Google for AIDE, you can check the file system integrity. Okay, and CipherScan is used to check what are all the ports that are opened on the operating system. So these two are pretty commonly used in telcos, but not the Linux. So in Linux, they stick to the RHEL, Red Hat Enterprise Linux only. But if you, for the security research activity, you should take a look at the Kali Linux. It comes built in with such an awesome tools with it. And next is the Linux Ansible hardening. This is what I was referring to, the security hardening part. So you can harden any operating system that you have, mostly around Linux variants thing, using Ansible. So there is a very good Ansible. You can just Google for this Ansible hardening. You can use Ansible. You are aware, maybe if you are aware of Ansible, Ansible is used for configuration automation process, right? So you can use the same Ansible tool for doing the security hardening. Okay, and this is the OS query. This is similar. It take advantages of the SQL based approach for for tagging and monitoring your operating system. So it's very popular incident monitoring tool. OS query and Go auditing. So this is more recent for even for the telcos use cases for supporting the auditing in the operating system level. So I think this is from the Slack. So the Slack has built this tool. So I just put the Slack logo there. So it's from the Slack company. Okay, and the next is the Surikata. So this is one of the very popular tool if you have already used it. If you haven't used it, I would request you to take a look at it. So this is again used for incident monitoring, keeping tracking of those on your operating system level. It can track each and everything. Say similar, very similar to Surikata, and equally popular is OSSEC. Both are very similar. If you're using Surikata, it is okay. It is similar to OSSEC, operating system security. And we have a Zeek tool. So Zeek was initially some I forgot the another name thing, but it was a Zeek it recently got changed to the Zeek security. So it is also very at a OS level for checking on monitoring your security issues. Panther, very under the same category. And Graphel. So you all these 1, 2, 3, 4, 5, they belong to the same category of incident monitoring or checking at the operating system level. Okay, for forensics, this is one of the popular from the Diffie. I think this is from Netflix. So if I'm right, yeah. So Netflix has created this tool for if some issue has happened, it can be used for the forensics. Okay. And if you are working with the public environment, AWS has published very good open source security tools. I've just listed 3. You can take a look at any of these 3, but all the 3 are pretty popular. But I have mostly used Security Monkey in this thing. Is much more popular than the other 2. And finally, we are all working with the Git nowadays, right? So with the Git, and even the telcos are working with the Git now, because all the VNFs, the workloads, right? They are tightly integrated with the telco clouds. So for example, in Samsung, whenever the new version of the workload comes, that can automatically come to, for example, in my data center in Bangalore, and it get upgraded to the new version. So that kind of automation is what we are talking when it comes to the workload automation upgrades thing. So for that Git, we have 3 very popular security tools: Git Leaks, Git Security, and Git Rob. So these are the very useful open source security tools that are used in the cloud. And if you really want to take a look at it and work on these tools, it will be very helpful. Finally, I would want to share on research trends in the cloud security, because considering the academic thing. So if this is basically, if you walk through the Google Scholar and see what kind of cloud security research activity that are happening, I could find 5 major trends. One is mostly around surveys. You will come across a lot of survey papers in Google. And I was pretty surprised by the number of the kind of surveys paper thing. So this is a common thing, but that really not interesting in many use cases. Okay, so surveys are pretty common. And there are multiple. Second most common is around the frameworks thing. So people have published multiple security frameworks for the cloud, different cloud use cases for some enterprises or from various use cases. So especially there is a strong need for such a framework for the telco use case. Yeah, so Lakshmi Narayan Balai, you have any question? Okay, maybe it was yeah, and how do I take this? And the next is around data security algorithms. So this is for especially for the cloud thing, but there are relatively lesser compared to the surveys and the frameworks thing. And there are some mechanisms that has been introduced to achieve security in cloud security, and majority of them are around service level agreements, CLAs thing. So how to introduce, how to ensure that the CLA is met by the provider, and what should be the mechanism you should follow. So this mechanism is the fourth most common publications that you will see, or the research trend that is happening in the cloud security. And finally, the techniques. So I could come across these three common techniques. Yeah, hi Vijaya Kamble. Do you have any question?
So just I asked the question. Sorry. Hello.
Yeah, tell me.
Yeah, that was my question. Just now you answered my question.
Okay. Okay. Yeah. And
Thank
when it
you.
comes to techniques, exact techniques, right? I could see these three as pretty common or well explored recently. Chaos engineering, and still I would suggest this is one of the lot of potential is available when it comes to the chaos engineering. So if you're looking to pursue some research in cloud security, I would really request you take a look at the chaos engineering. And chaos is what there are I think only one or two companies that are there who have built the products around security using the chaos techniques. So basically to create chaos and see how the cloud behaves, right? So this and using genetic algorithms and Markov chains are other common things, but chaos engineering is a very good potential is there for that. So this is just for you guys to consider if you want to pursue the research activity in cloud security. So these are the common trends that I have come across and I wanted to share with you.
Sir, one more question. As you said that there is lot of potential for cloud security research, but cloud is paid service, right? So are there data sets available uh, for the assessing the networks and doing the research? Like if you have the data set, particular sites and all, so you can take the
No,
data. Because
see,
most of
cloud is
the cloud services, they are paid services. So
no, that's what that's paid if you are looking from the user perspective. But as a researcher, right, you should also look from the provider perspective. So if you are offering the cloud services, that is when you should address the security challenges. See, from the user perspective, your challenges are very few, right? At most, you focus on the mechanisms to ensure that the provider is providing you the security thing. But as a researcher, I would focus more from the provider perspective.
but see, if we target telco suppose, so for service level agreement, whether they will provide us the data for analysis or like. Uh,
See, if you are a customer of that telco who are taking, for example, platform as a service, they have to provide you the data.
okay.
Okay. So, but when it comes to your research activity, for example, if you want to, in majority of the research, right, you have to focus from the provider perspective. The challenges provider has today to provide the security measures, whatever the 8 categories I showed, or if you want to bring in new mechanisms to provide security using these techniques, if you want to work with it and if you want to test your things using the real world data, they'll be happy to collaborate through the university thing.
Okay.
But it's very difficult for an individual to get hold of the real world data from telcos. But nowadays, you have to rely on your
Yes,
simulation of
yes.
thing.
So that is the reason that survey papers are more than the real research. because
Uh,
most of the things they are not open to the
yeah,
academia.
correct. So that is where it's important for to actually start the collaboration or join the communities like Linux Foundation. So communities like Linux Foundation, right? So the telcos are also part of it. So in such a scenario, for example, I work with the Linux Foundation, and I have a lot of access to this telco data itself, because telcos are also part of that work. So as a researcher, you should definitely consider working with this open source community where telcos are also there, who can provide you the data.
Thank you, sir.
Yeah. Okay, so I think that's all I had for to share. I have 4 more minutes. If you have any questions, I'll be more than happy to answer. Of course, if you have more, I can.
Sir, what according to you is the most vulnerable sector for security in telcos?
Mostly the work, the platform part is more or less it is fixed. It's mostly from the workloads part. Okay, so when it comes to the workload, right now, as I said, it has been a lot of vendors have come. Earlier, it used to be only Cisco's or Juniper. Now there are so many software companies, even like Wipros and Tech Mahindras are also coming up with the workloads, right? So for them to ensure that these workloads are much more secure compared to the other ones is the biggest headache for them. The workload security is more challenging than the platform security.
Sir, as a researcher, I'm about to start my PhD. I have a 1-year time gap for myself to prepare. But so I asked this because I want to look into the sectors, because the sector needs to be like open for work, because most of the sectors, once they open, they dry up very soon for the topics.
And also see these things, right? There are a lot of open sources, the VNF network functions, right? So all the network functions, majority of the network functions, you will have open source. So for example, if you want to set up a small telecom network within your campus, you can do that. You can have your own private wireless telecom network within your campus using only open sources. So for example, if you Google for virtual EPC, open source.
Okay.
So virtual EPC, if you Google, and you can download today, there was many open sources around virtual EPC. So you can buy a few antennas, 2 to 3 servers, and you can set up a LTE network in your campus today. So
That's a great thing.
virtualization that is brought in.
Thank you, sir.
Yeah. So you can do if you can collaborate with maybe another person in the university or maybe another university, you can set up your own private network and do excellent research. So it could be a good research proposal. Also, you can take it to DSA and these kind of funding agencies who will be more than happy to fund in these kind of activities actually.
Sir, can we have your mail ID, please? Because the chat box is not open for further any communications with you.
Okay. Okay. So either.rao@spirent.com. Okay.
Thank you, sir.
Sir, I have a question regarding cloud infrastructure.
Sure.
Yeah. So, sir, this is very basic question, but yeah, actually, I understand server virtualization. So, if there is some server with very good configuration, then you can have multiple virtual machines. But if there is a requirement of having high performance computing infrastructure, so like when cloud is providing such server, so is it that the cluster is the underlying structure? Should I repeat the question? It's
Yeah,
basically
please.
like in server virtualization, there are multiple virtual machines on a single physical machine.
Yes.
Right? But if I have a requirement I have a huge requirement, huge computational requirement with single IP. Maybe I need some high performing server. And so do they club multiple machines and cluster it and then provide it as a single machine to the end user or to the customer?
Very good question. So you can actually, this is not a bad question actually. So what in this cloud, right? So they, along with virtualization, they also can, and in these requirements, they also provide what the service is called as bare metal service. So there are two options for you. If your application is not parallelized, for example, you cannot run multiple instances of it across the virtual machines and then combine it to a single logical thing, then if you cannot do that, then you can go for the bare metal as a service. So it's called bare metal as a service, BMAS. Okay.
Okay.
My application, you cannot run it over multiple virtual machines, sir. So I need a one single server with such a big capacity. So there'll be more than right.
Okay.
It comes under the bare metal as a service, where you're asking for a one single bare metal, not the virtualization thing.
Yes. Yes.
Yes, the BMAS is the solution.
Okay. So, but the my question is about the underlying structure. For end user, it might be a single machine, but is the underlying structure also single machine, or it is it is cluster?
You can ask for it. If you want it the way you want it, they will provide it.
Okay. 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 Thank you, sir.
Sure. Okay. So if you have any questions, further questions, please feel free to mail me. I will be happy to answer whatever I know. Okay, guys. Thank you. Thank you very much. Have a nice day.
Thank you, sir.
It is my host, Surendra. Yeah. Hi, Surendra. We are done, right? Do we still have him?
Thank you, sir.
Yeah. Hey, thank you very much, guys. Thank you.
Can we leave, sir? Surendra, sir? Thank you very much.